Hello, welcome to sub day number one. Thank you so much for being polite and kind to Miss Jackson Cloy, if that's who's here. That's who is scheduled to be here, but sometimes people get sick or need to make changes. So the following pages go along with the Ed puzzle. So I'm creating the Ed puzzle right now. Please open both of these assignments. This is a work day for you. Remember, when you have a guest teacher, what the guest teacher says is law, even if it goes against my normal expectations or routines. Y'all are generally very respectful to me. And so I don't expect there to be any issues. Please be your amazing selves. You guys are really rock stars. So just do what you would do, but even better with me. Does that make sense? Okay, let's go ahead and get started. Now, some of the problems on the next page are things that we didn't go over this. You're right. We didn't. There's not enough time in the year to go over everything, especially when there was so much backfill to do with all the absences because of COVID. So I'm going to use this opportunity to try to teach it to you the best that I can, so that if you come across it, maybe you'll remember, but don't let it discourage you, okay? Try and then watch the video and try to absorb what it's saying. Okay, so the first one is a geometry question. Okay, so here's the deal. And this should not be new to you. If you were here in sixth grade, we did go over some of this. When there is a little square here, that means that is a 90-degree angle. That means that this angle measures 90 degrees from there to there. So it's 90 degrees from this line to this line. They're what's called perpendicular. Perpendicular means it's a perfect 90-degree angle. Okay. So we call this angle WVY because it starts at W, it connects at V, and it goes to Y. We call the other angle YVZ. Okay, so all of it together equals 90 degrees. So the whole thing, X plus 2X equals 90 degrees, because X, the measurement of from here to here, plus the measurement from here to here is 90 degrees. So now that we have this, we can treat it like we've treated the other ones that we've done. 1X plus 2X's is 3X, right? Okay, so 3X equals 90 degrees. We're going to divide both sides by 3 to find out what just X is. So 90 divided by 3 is, and you can use a calculator, look, is 30. 30 equals X. So what we've got now is we've got X here. So that's just 30. So that's going to be what we're going to call 30 because it's 30 degrees. This tells me that X is 30 degrees. This one is 2 times X, so 2 times 30. So this one is going to be 2 times 30 is 60. 60 plus 30 equals 90. Now the question is asking, what is the measurement of WVY? So here's W. I'm going to do this. WVY. So we want to know what the measurement is of that one right there. Well, that one we just figured out is 30 degrees because X equals 30 degrees. We didn't even have to go figure out what the other one was. All right. Okay, in this diagram, the measurement of the angle ABD, so ABD plus the measurement of DBC is 90 degrees. So it's telling us that it is 90 degrees from there to there. If we take out this line here, this D line, then it's 90 degrees. It's also telling us that the measurement of ABD A, B, D is 30 degrees. So it's 30 degrees. What is the measurement in degrees of D, oops, I want this one, of D, B, C? Well, if the whole thing is 90 degrees and this one is 30 degrees, then the rest of it is going to be the other angle, right? So 90 minus 30 is 60. So that means that from here to here, it's 60 degrees. Right? So that would be a big fat 60 degrees. Okay, next page. This table shows a proportional relationship between the grams of peanuts and raisins in a bag of trail mix. Enter the grams of peanuts in a bag for every 1 gram of raisins. So basically what we're doing is we're getting this down to 1 gram of raisins, and we need to find out what the ratio is of grams of peanuts. So we can do that by taking any one of these numbers. I'm just going to go ahead and go with 4. To get 4 to become a 1, we divide by 4. 4 divided by 4 equals 1. So whatever we do to one side, we have to do to the other side. So we've got to take 14 and divide it by 4. And we can use a calculator on this one. So I'm going to. 14 divided by 4 equals 3.5. So that means that this number here is going to be 3.5. So there would be 3.5 grams of peanuts for every 1 gram of raisins. All right. Next page. Okay, this one is a little bit more complicated. So we did not go over box plots this year. It's possible that your 6th grade teacher did. I can't remember if I went over them last year or not. But Mr. Ostrander may have, and Ms. Wilbert may have. And I just don't remember if I did or not. Box plots are another way to show a graph. So here's the basic idea of how a box plot works. So when you have a graph like this, there are 4 different categories of understanding. There's what's called the range, which is the highest to the lowest. So for example, the range of Mr. Cooper's class is from 32 to 46. Ms. Parker's class, the range is 34 to 46. So the range goes from the lowest to the highest. So it tells you just kind of the spread, okay? The other thing you have is what's called the median. The median is the middle number. It's whatever the middle number is. Then you have, I'll put middle here. Then you have another thing that you can, another measurement that you can use from this, and it's called the mean. And the mean is the same thing as the average. So the average. Okay, so the average is when you take all of the numbers together and you add them together and you divide by the number of numbers and try to get it distributed. And the last one is called the mode. We don't have to worry about the mode a whole lot with box and whiskers, but the mode is the number that shows up the most. Okay, so when you're doing data collecting, these are the 4 different ways that you can use to kind of interpret the data. With this box and whisker, they call this box and whisker or box plots. We really use the mean and the range and the median. Those are the 3 things. We don't really deal with the mode. Okay, so here's how they work. There's a whole group of data, and it says that the box plot shows a summary of the number of students present in Mr. Cooper's class and Mr. Parker's class during the last month. Okay, so we are going to determine whether each statement is true based on box plots. So we call this the inner quartile because it's in 4 different parts. We got 1 part, 1 quarter, 2 quarters, 3 quarters, 4 quarters. we got 4 different quarters of the box plots, okay? The middle here represents the average. This is where I might be getting this wrong. I have to double check, and I might make an addendum to this video. Okay, so you take all the data. Basically, there's 32 students were there and 46 students were there. And you have to break them up into 4 equal parts. We've got I think it's the median is the middle number. So this tells me that 37 people, you have this whole list of data, like 20, 32, 36, 35, all kinds of data, right, for the last month. And the one, if you put them in order from least to greatest, the one that's in the middle represents this line right here. So 36 and a half. And in Mr. Parker's class, it's 40. So let's read some of the statements, and maybe that'll guide the conversation here a little bit. The interquartile range of students present in Mr. Cooper's class is less than the interquartile range of Mr. Parker's class. This is the interquartile. They're saying that Mr. Cooper's class is less than Mr. Parker's class. And if I do this and bring this straight down, they're actually equal. They're not less, it's equal, right? So we have a lot more. The range is bigger, but there's, and it says the interquartile range. So absolutely, the range is only from 36 to 38 here, and here it's 36 to 45. So the interquartile range in Mr. Cooper's class is, in fact, less than the range of Mr. Parker's class. Okay? So let's look at the next one. The median of students present in Mr. Parker's class, so here's Mr. Parker's median, is less than the median students in Mr. Cooper's class. No, that's not true. Mr. Cooper's median is less than Mr. Parker's. And then the last one, the range of students. So range of students is from here to here and from here to here. The range of students present in Mr. Cooper's class is less than the range of students present in Mr. Parker. No, Mr. Cooper's class has a wider range. It goes from 32 to 36. 46. Mr. Parker's class goes from 34 to 46. It's a bigger line for Mr. Cooper's class. So this one is also false because it's actually the opposite of what they're saying. Okay. I know. It's going to be kind of difficult because of we didn't quite get to that, but hopefully that gives you enough to be able to figure it out. Most of them are kind of common sense, so do your best guess. All right, so now you're not going to be able to actually drag the arrow on this one because this is just a copy of the page. But on the test itself, it will be a copy or a drag. So it's definitely not these two because these mean greater than or less than and equal to, but this is not. So it's going to definitely be one of these. Look at your inequality and decide if it's an open or a closed circle. Okay, so let's go ahead and do the work here. We want to get x all by itself, so we're going to add 4, and we're going to add 4. So that means we've got 6x on this side, because these cancel each other out, and 8 plus 4 is 12. Now we're going to divide by 6 to unglue that, and we're going to divide by 6. So that means x and 12. Now remember what I said yesterday. Yesterday I said we only flip the inequality if we divide by a negative number. We did not divide by a negative number, so it actually stays exactly the way it was. We don't flip it just for division in general. We only flip it for negative division. All right, so x is less than 12. Sorry, is less than 2 because 12 divided by 6 is 2. So it is an open circle, and X is less than. So it goes there. Okay, last one. Marcus has a pool that can hold a maximum of 4,500 gallons of water. The pool already contains 1,500 gallons of water. So it starts out as 1,500 gallons. And it can go up to 4,500, and it can be equal to or less than 4,500. Marcus begins to add more water at a rate of 30 gallons per minute. Enter the inequality that shows the number of minutes in M that Marcus can continue to add water. So we're going to do plus 3, because it's 30 gallons, so 30 gallons per minute. So it starts out as 1,500, and we're going to add 30 gallons per minute, and we can add until we get less than or equal to 4,500. We don't want to exceed the maximum number of gallons. So that's the inequality. It would look like that. We know that we can't go over 4,500. But it can be equal to 4,500. We started with 1,500, and we're adding 30 gallons per minute. So we can keep adding that 30 gallons per minute until we get to that point, but it's whatever is under. It's a number that is less than that. So M can be anything less than that. All right, that is it for this one. Hope you had a great day. Please continue to be kind to the substitute if you finished early.